Right, this is the second video for section 1.2. We're going to do two examples where we model growth and decay. You definitely want your calculator handy, and I do want you to practice using your calculator as we go through these examples. Don't just wait for me to do the calculations or give you the answers. You need to actually practice physically using your calculator so you're able to do it when you're on your own on a quiz or a test. All right, so the first example, I recommend taking a minute to write some of this down. It's about shoes. You're buying a pair of limited edition, and then immediately you sell them on an online auction site. You don't actually want the shoes to keep. You're trying to make a little bit of money. The bidding starts at $100, so that's the price you put at before any bidding happens, $100, and each bid pushes the price up by 15%. We are going to write a recursive formula and a shortcut geometric formula to represent the situation, so two different formulas, and then we're going to figure out if the 10th bidder purchases the shoes, how much will that person pay? Well, the first question I have for the recursive formula, are we going to use u sub 0 or u sub 1? And since the bidding starts at $100, so before anything happens, we've got $100 going on. I'm going to call it u sub 0. If you picked u sub 1 on a test or a quiz, that's fine. I'll figure it out, but it's worth trying. All right, so our recursive formula, this is definitely geometric. The price is going up by 15%. So let's get ready. We need a recursive formula, and then we're going to do our shortcut formula, and then eventually get an answer. So recursively, u sub 0, the price is at $100, and now let's write a rule. When there's recursive, again, two parts, we need to figure out what that ratio is and multiply it to the previous term. Well, let's figure that out. If the price goes up by 15%, we know we have 100% of what the price really starts at. Got to get back to the beginning, and then it's going to go up by 15% of that. So 100% as a decimal is 1, 15% as a decimal is 0.15. So my ratio is 1.15. That 1 represents getting back to 100% where we started. That 15 shows the growth. So the ratio is 1.15. It'll go right there into your recursive formula. So what we could do at this stage is to find the 10th bidder, we could just go out the 0th, the 1st, the 2nd, the 3rd, and keep going all the way till we get to the 10th. That's totally a fine way to do it, but let's try the shortcut. What we learned at the end of the last video is that we're going to start at 100, and then every single time our multiplier will be 1.15, just like down here. You'd multiply the values by 1.15 each time. And how many times do we have to do that? Well, the 10th bidder, so we're going to raise to the 10th. All right? So here's where it's easier with your calculator to just simply punch in 100 times 1.15 raised to the 10th. And that gives us right around, since this is money, I would say $404, and let's round that to 56 cents because it's 0.555. You always want in money round to the nearest hundredth or the nearest penny. So we have the answer, $404.56. Not bad if you buy a pair of shoes and you resell it right away. You made a nice little profit there. All right, one more example, money in the bank. This one you definitely want your calculator out. This one has a few parts. It'll take a minute, but it is important and will help you on a quiz, homework, and a test. So this is money in the bank. Gloria deposits $2,000 into a bank account that pays 7% annual interest. You don't withdraw or deposit any additional money for 4 years. This is definitely an example you want to write down. Gloria deposits $2,000 into a bank account that pays 7% annual interest. I wish my bank paid that much. You don't withdraw or deposit any additional money for 4 years. The first question says to write a recursive formula and geometric growth formulas to represent the situation. This idea of a geometric growth formula, I'm thinking that's like our shortcut one that we'll do. All right, so recursively, I'm going to use U sub 0 because we deposit $2,000 into the account. So that's how much money is in there before any time passes, before any interest or growth happens on it. And then recursively, to get the annual interest that's every year, to get how much you have the next year, it's going to grow by 7%. Well, let's think about that. 7% as a decimal is 0.07, and then we need the 1 in front to show the growth. Remember, the 100% gets us back to the 2000, the 0.07 gets us to that 7% growth, and you'd multiply that by the previous year's amount. So to find that first one, you would simply do 1.07 times 2000, and then you could keep going and see how it grows. If you want the shortcut formula, a geometric growth formula, then we'll think of it as the amount of money we have. It started at $2,000. It's going to grow by that 1.07, and you could either raise it to the n or the x. Some of you might be more comfortable instead of u sub n saying y equals, and instead of n writing x, but it's the same thing. If you think of it as that n is the number of years and u sub n is the value after that same number of years. Okay? So part A, write a recursive formula and geometric growth formula to represent the situation. Does our recursive formula have two parts? It sure does. I think we're pretty good for part A. Then it says, if interest is paid once per year, what will the balance be after 4 years? Well, you certainly could use the recursive formula, and on that 0th year, it starts as 2000. And you could certainly, with your calculator, multiply by that 1.07. Oops, I wrote that wrong, 1.07. You could use the table function on your calculator that we practiced. I'm going to use that geometric shortcut. To me, that seems the easiest, because all I have to do is 1.07, then raised to the 4th. So in my calculator, I've got the 2000. You can't really see that, can you? Times 1.07 raised to the 4th. That totally got cut off over here. I recognize that now. I didn't notice that before. I'll try to fix that for the next video. But if you look over here, it's smaller, but you can see it. We're right at about $2,621, and I'm going to round that to 59 cents. So we get $2,621.59. And there's that part of the smartboard that likes to be kind of crabby at me. All right, so 4 years, the money's just sitting there. You've gained over $600, not bad. Let's move on to the next part. If the interest is paid every 6 months, what will the balance be after 4 years? This is also referred to as 7% compounded semi-annually. So semi-annually, that means it's happening every 6 months, 2 times in a year. Where here, when the interest was paid once per year, that would just be annually. All right, so what we have to do is to divide that annual interest rate by 2 to find the semi-annual interest rate. So let's practice that. We've got the 100%, the 1, and then plus that growth of 7% annually per year. But this, they're going to compound it semi-annually. So that means that 7% is divided in 2. So you would end up getting a 1.035 is now our interest rate. Okay? So that gets a little confusing because the annual interest rate didn't change. It was still 7%. But now they're compounding it semi-annually twice a year. So you take that 7% divided in half to get that 3.5 or 1.035 for semi-annual. So then to figure out how much money you go, we'll still take that 2,000, and now instead of times a rate of 1.07, it's a rate of 1.035. But now here's the question. When it was done annually, that n equaled 4. Semi-annually, well, let's think about that. It's happening 2 times a year for 4 years. How many times is the interest going to be compounded? It's going to be compounded 8 times. So our exponent is to the 8th now. And that lands us at $2,633.62. Pretty close. Not a big difference, but a little one. That compounding semi-annually lands you with a little bit more money. All right? What will the balance be if it's 7% annual interest compounded quarterly for 4 years? So this would require that you know what the idea of quarterly is, and that's 4 times a year, where semi-annually was 2 times a year. So that's a good vocabulary word to make sure you know. All right, so let's figure out what that interest rate will be. We need the 100% to get back to where we started. That's the 1. And then there's the 0.07 is the annual interest rate. But if it's been compounding quarterly, this time we divide it by 4, and that gets us to a 1.0175. So now when we plug into our equation, we started with $2,000, but it's going to happen quarterly. So we're going to use this 1.0175. And now let's think about this. It's going to happen 4 times a year for 4 years. That means it's going to happen 16 times. So we'll have an exponent of 16 right there. All right, so when I plug that into my calculator, I've got 2,000, and now, what was it? 1.0175. And this one will be raised to the 16th power. $2,639.86 is what I will get it. So again, a little more money. So we like it when it compounds a little more often. $2,639.86. Quick question here as a follow-up. What if we were going to be compounded monthly? So it's still a 7% annual interest, but we're compounded monthly this time. Well, you'd have the 1, and the 0.07 would be divided by 12 because there's 12 months in a year. And what would the exponent be? 12 times a year for 4 years, your exponent would be 48. All right? What if I asked you if it was happening daily? We had 7% annual interest compounding daily. Let's try to get away from that spot on the smartboard that is bad. We'll see if I can do it. Compounding daily. Well, I suppose you could get kind of funny. I would argue it's 365. Some of you might argue you divide by 365 and a fourth because of leap year. I suppose we could debate that a little bit. So, sorry about that. Got into some private photos. I didn't even know those were available. Oh, anyway, sorry. We could debate if we wanted to include leap year or not, but we could think about this. If that, let's just kind of not account leap year into it. 365 times a year for 4 years. Then our exponent, that n value, would be 1460. It would be a lot. So just trying to think about on your homework or on a test, it'd be very likely that you're going to be asked for annual, semi-annual, quarterly, or maybe even monthly. And you're going to want to make sure you would know how to handle this part right here. So you'd have to know what number goes here and then think about what your exponent would be. So hopefully you took some time to take some notes here and to really highlight and think about what these problems, how you'd solve them, because you'll see them again. All right, that's it for 1.2. Please go back to the Schoology page and see what you have to do next. My guess is you show up for class the next day we have class, either online or maybe you'll be with me in the classroom. I'll answer a few questions and you'll get a practice assignment. Thank you so much for your attention.